Well, welcome back. That's right, it's as easy as ABC and 1, 2, 3. Our topic today is trig equations with identities. So when I say identities, what exactly am I talking about? Well, first, we have the double angle identities. And we have the half angle identities. And these are nice because they're actually given to us on our reference sheet, so go ahead and take that out. And lastly, the other identities that you have to be familiar with are the Pythagorean identities. And those are the ones we said you have to remember, also known as our godfather of trigonometry rule. Okay, and that's, hopefully you'll recall sine squared theta plus cosine squared theta equals 1. So let's go ahead and dive into some trig identity questions. Question 1. Find to the nearest tenth of a degree, so we know we have to round, we're going to need our calculator, all the values of theta between 0 to 360. Notice that we're including 0, but not 360, that satisfy this equation. Now, what's wrong with this equation? Well, don't jump the gun on these. Some people get so excited they just dive right in and you miss the important part. We have a sine squared and a cosine. That's like solving the equation 5x squared minus 9y minus 3 equals 0. Well, you can't factor that, and you can't use quadratic formula. You don't have the same variable. Okay, so our whole trick is we need to see the same trig function. Okay, you've got to get the same trig function, and I'm just going to say 99% of the time. All right, it's not all the time, but it is 99% of the time you need to see the same trig function. So my goal is to get rid of one of them. The other thing I like to get rid of is, I'm going to make a note, get rid of the squared term. Okay, so out of the two, I'm going to get rid of the squared term. Now I can do that because of the godfather rules. So let's jot down this equation again. 5 sine squared theta minus 9 cos theta minus 3 equals 0. Okay, so I can get rid of the squared term. That's my goal. Let's kind of just box that in. Just the squared term, not the 5, just the squared term. And say to yourself, what special formula has sine squared in it? Okay, and we're going to write that off to the side. Well, it's that godfather rule we told you to memorize. Sine squared theta plus cosine squared theta equals 1. And you want sine squared theta by itself. What would you do to get sine squared theta by itself? Well, hopefully you'd say that's equal to 1 minus cosine squared theta. Basically, I would just subtract that term from both sides. So I'm going to replace the sine squared theta with 1 minus cosine squared theta. Now, is that legal? Well, of course, because they're equivalent to each other. Okay, so again, I'm just saying sine squared theta came from one of the identities, the godfather rule. I solved for sine squared theta and substituted it in. Okay, now just common sense, let's just take that 5 and distribute it. 5 minus 5 cosine squared theta minus 9 cos theta minus 3 equals 0. All right, I'm going to keep cleaning it up. I've got to put my squared term first, so I've got negative 5 cosine squared theta minus 9 cos theta, and then of course 5 and a negative 3 make a positive 2. Now, most people don't like to factor or use quadratic formula if the first term is negative. So here's a fair game. You can change that as long as you change everybody's. So basically, I'm multiplying both sides by a negative 1. And notice I'm including it with the 0 also. Everything gets multiplied by negative 1. So this becomes 5 cosine squared theta plus 9 cosine theta minus 2 equals 0. And that's fair game. Okay, now does it factor or quadratic? I'm going to go with my rule of thumb. If there's only one option, then I think guess and check is easy. 5, my only options are 5 and 1. And 2, my only options are 2 and 1. So this is an easy guess and check. So I'm going to go with guess and check over quadratic. I'm going to say 5 cos x and cos x. And now I just have to determine where the 1 and 2 go. I'm going to guess 1 here and 2 here. My insides give me 1 cos x. My outsides give me 10 cos x. Can you get a 9 out of that, a positive 9? Well, this would have to be positive, and this would have to be negative. That multiplies to a negative 2 and adds to a 9. So like I said, if there's only one term to guess and check, I prefer that method. So I've got 5 cos x minus 1 equals 0, and cos x plus 2 equals 0. Okay, now we're just going to solve each one separately like we did before. So I've got 5 cos x equals 1, cos x equals 1/5. All right, 1/5 is smaller than 1, so I know there's an answer. I'm going to need to determine quadrants and a reference angle. All students tipped cows. My cosine answer is positive, so I can be in the all or where cosine is. So my two answers are in first and fourth. I need to get my reference angle. All right, so I'm going to inverse cosine of 1/5. And I get 78.463, which of course I'm storing into alpha A. Okay, so in quadrant 1, I am my own reference angle, and I believe, I better go check, I think we were rounding to the nearest tenth, did we say? Oops. Nearest tenth of a degree. So that's going to get me 78.5 degrees. And in quadrant 4, here's my reference angle, so I need that whole thing. So that's 360 minus A. Gets me 281.5 degrees. Okay, on the other side, I'm going to say cos x equals negative 2. All right, is it possible for the cosine graph to hit negative 2? Well, of course not. So if you try to take the inverse, you should get the error sign. And that's a good thing. The graph does not hit negative 2. So I only have two answers, 78.5 degrees and 281.5 degrees. And there you have it, solving a trig equation with our first Pythagorean identity. Number 2, find to the nearest 10 minutes or nearest tenth of a degree all the values of theta in the interval 0 to 360 that satisfy this equation. Okay, so what do you have to pay attention to again? Make sure 99% of the time all of those trig values are the same. Okay, and are they the same? Well, no. And remember, our trick was we can usually get rid of the term that is squared. So go ahead and just box the squared term in. Now ask yourself, where does cosine squared come from? Well, it comes from those Godfather rules. Sine squared plus cosine squared equals 1. And you want to get the cosine squared alone. So what would you do to both sides? Hopefully you would subtract over the sine squared. So I would say cosine squared theta equals 1 minus sine squared. So that's what I can replace in this cosine squared. So I should have 4 times, in place of cosine squared, 1 minus sine squared equals 3 plus 3 sine theta. Okay, so now we'll just clean it up, common sense. Let's distribute. 4 minus 4 sine squared theta equals 3 plus 3 sine theta. Now, before I do anything, I want to make my equation equal to 0. So I've got 4 minus 4 sine squared theta. I'm going to subtract the 3 over and subtract the 3 sine theta over, and then put my like terms together. And I think that leaves me with a plus 1. Now again, most people don't like to factor if this term is negative. So I'm just going to go ahead and multiply everybody by a negative 1. So I get positive 4 sine squared theta plus 3 sine theta minus 1 equals 0. Now at this point, I'm going to assume for the most part that we can solve these equations. We will go further in class, but my goal was just to clean it up so we can practice solving them in class. So my goal is to substitute and we're good to go. So I don't want you to go any further. We're going to go ahead and set up another one. Solve algebraically for all values of theta in the interval 0 to 360 that satisfy this equation. Okay, so a couple things you could do right off the bat. One easy thing you could do is probably put this over the number 1, and you could do a nice cross multiply. 1 times sine squared, so I've got sine squared theta, equals 1 times 1 plus cos is 1 plus cos theta. All right, now we've done this twice now. Which of these three terms do you want to replace with something? And remember, it's always easier to get rid of the what term? The squared term. Okay, so go ahead, use your Godfather rules, and go ahead and substitute something into sine squared. I'll pause it and give you a moment. Hopefully you're putting in place of sine squared theta 1 minus cosine squared theta equals 1 plus cosine theta. All right, I'm going to set this equal to 0. So I'm going to subtract these terms over. Subtracting the 1, subtracting the cosine theta. 1 minus 1 cancels nicely, so I've got negative cosine squared theta minus cos theta equals 0. And again, most people don't like to factor or do anything math until we have a positive squared term. So I'm going to multiply everything by a negative 1. And there you go. Now we've got a nice trig equation. What type of factoring could you do on this one? Hopefully you've guessed it. I think I heard you. GCF. You could pull out a cosine. And on this term I'd be left with cosine theta, and then of course plus something. I've got to have a plus 1. All right, let's go ahead and solve this one. All right, so now I'm just setting each term equal to 0. So I've got cos x, or theta, equals 0. And here I've got cos theta plus 1 equals 0. Okay, now when 0 and 1 and negative 1 all come from the trig graph itself, how many times does the cosine curve hit 0? Well, it looks like you should have 2 answers. What are those tick marks? Well, that was my pi over 2 and 3 pi over 2. And on this side, I get cos theta equals negative 1. So that 2 comes from the graph. I'm going to steal the graph I had here. It hits negative 1 one time in my green dot there, and that's at pi. So I would say I have 3 answers. Pi over 2, 3 pi over 2, and plain old pi. All right, find all the values in theta between 0 and 360 that satisfy the equation 3 cosine 2 theta equals 7 cosine theta. Okay, now these are going to get sneakier and sneakier, so you've got to pay attention to the details. Okay, the details make a big difference. Read this term. It's not cosine squared. It's not using the Godfather rule. It says cosine of 2 theta. What did you do to the angle? Remember, when you multiply by 2, that's the same word as doubling. And that's where that formula sheet that you have is going to come in handy. You got a double angle this time that you have to make a substitution on. So you just go to your sheet, you match it up. There were 3 options for cosine of 2 theta, and you want to pick the smartest one. Basically, you say to yourself, if you were to take cosine of 2 theta out of the picture, which trig function is still in the picture? Well, I still see a cosine. That means out of the 3, I'm going to pick the one that only deals with cosine, and that would be this third one. So I'm going to say this is 3. In place of cos 2 theta, I'm substituting in 2 cosine squared theta minus 1 equals 7 cos theta. Now you'll notice I'll have all of the same trig function. So common sense will be to distribute that. So I've got 6 cosine squared theta minus 3 equals 7 cosine theta. We'll set it equal to 0. So 6 cosine squared theta minus 7 cosine theta minus 3 equals 0. This should be a fairly nice guess and check. Even though this is 6 and 1 and 2 and 3, the only option here is 3 and 1. So I'm going to try my guess and check factoring again, or feel free to jump to the quadratic formula. So again, I could use 6 cosine theta and 1 cosine theta. And then I've got a 1 and a 3. So if I went 1, 3, that would give me on the 18 and 1, which would not make 7. So if I go 3 and 1, that's going to get me a 3 and a 6, which would not make 7. So those aren't going to work at all. Let's try 2 cosine theta and 3 cosine theta. Oh boy. So again, I'm going to go 1 and 3. So that would be 6 on the outside, 3 on the inside. That doesn't work. 3 and 1. That's going to be 9 and 2, and that would get 7. Okay, so I'm just going to make it a little neater. I think I'm going to go with 2 cosine theta and a 3 and a 3 cosine theta and a 1. So let's just verify. Inside, I've got 9 cosine theta. Outside, I have 2 cosine theta. If I want a negative 7, that means the 9 has to be negative and the 2 has to be positive, so that's negative and that's positive, and those ends multiply to a negative 3. Beautiful. All right, set each piece equal to 0. So 2 cosine theta minus 3 equals 0. So there's my teeing it up. And 3 cosine theta plus 1 equals 0. All right, so I've got on this side, cosine theta equals, add the 3, divide by 2. Cosine theta is bigger than 1. Is that allowed to happen? Can the cosine graph be bigger than 1? Hopefully you're saying no solution on this side. And on this side, I've got cosine theta equals, subtract the 1, divide by 3, negative 1/3. Now, I do have answers here, so I've got to take my time. Let's talk quadrants. All students tip cows. I'm cosine and I'm negative, so I can't be in the all and I can't be in cosine. So my answers are in quadrants 2 and 3. I need to get my reference angle, so here's the part I have to slow down on. Okay, I already took care of the negative, so I should just be doing inverse cosine of positive 1/3. And that gets me an angle of 70.528, which I'm storing into angle C. Okay, so in quadrant 2, here's my reference angle. So this angle is actually 180 minus angle C. And I believe it said nearest tenth, so I'm going to go with 109.5. And in quadrant 3, here's my reference angle. That's 180 plus angle C. And that gets me 250 to the nearest tenth, 0.5 degrees. Okay, so my two solutions, 109.5 and 250.5 degrees. Alrighty. Solve for x to the nearest tenth of a degree. 4 cosine 2x minus 2 cos x plus 3 equals 0. Alright, so is it a Godfather or is it a double angle rule? And just read it. If you don't say squared, it's not a Godfather rule. 4 cosine 2x. I'm taking the x and multiplying it by 2, which is known as a double angle. Remember, these are given on your exam sheet, your formula sheet. Minus 2 cos x plus 3. So let's walk through the trick one more time. You recognize the double angle, and you say, I'm going to take that out of the picture. Which trig function is still left in the picture? If I replace that, the only one I see left is cosine. So out of the 3 options you have, pick the one that only has cosine in it. So I'm going to say 4, and then replace that with 2 cosine squared, theta minus 1, minus 2 cosine x, plus 3 equals 0. I guess I should call this x just to be similar. Again, I would distribute this through. So 8 cosine squared x minus 4 minus 2 cos x plus 3 equals 0. Keep cleaning it up. I get 8 cosine squared x minus 2 cos x minus 1 equals 0. Again, at this point, I'm going to assume we can either, quadratic formula or factor, and I really just want to practice making the substitution. So we'll call it good here, and let's try another setup. Here we go with another one. Find all values of theta in the interval 0 to 360. Notice I'm including those numbers that satisfy the equation. So let me rewrite this. Sine theta equals 2 plus 3 cosine of 2 theta. Express your answer to the nearest 10 minutes or nearest tenth of a degree. Alright, so remember, I need all the same trig function, and hopefully what's jumped out at you is this double angle for cosine. So I think we've done enough examples. Why don't you go down to your double angles and determine which one the best one is to substitute in, and clean it up from there. I don't actually want you to solve it, I just want you to make the correct substitution and pause it and try it on your own. So my idea was that if I were to take this double angle of cosine out, the only trig function I see is sine. So out of my 3 options, I'm going to pick the one that only deals with sine. So I'm going with this choice. Hopefully you did the same. So I've got sine theta equals 2 plus 3. And now notice I'm replacing this, so I'm using the quantity or parentheses, 1 minus 2 sine squared theta. All right. Now, order of operations. I have 3 times this quantity, so I'm going to distribute this 3 through. So sine theta equals 2 plus 3 minus 6 sine squared theta. And then, of course, I want to set it equal to 0. And I've got two like terms here. So check my math here. Hopefully you've got the same thing. I've got negative 6 sine squared theta. I'm subtracting the sine over. And 2 plus 3 is 5. And lastly, before I, solve this problem, I would probably multiply everything by a negative to change the sign, so I had a positive 6 sine squared theta. Okay, and like I said, I don't think we need to solve it. We're going to get enough of that in class tomorrow. I just want to make that correct substitution, and now note that I can solve this easily because everybody is in terms of sine. Well, I think that does it for us tonight. We look forward to seeing you tomorrow. Have a great night.